everybody, to another episode of Dr. Matt and Dr. Mike's Medical Podcast. I'm your host, Dr. Mike Todorovic, joined by this lazy slacker, Matt Barton, who has just come back from holidays. This is the reason why, lady and gentlemen, our 1 to 2 audience members...
This is actually an old cup.
Okay. This is the reason why there was a bit of a break between some episodes, and that's because this guy decided to go to New Zealand with his family.
Well, that's because I didn't get a break during the Christmas New Year's period because we got like 15 different natural disasters.
That's true. Yes,
and
your whole property got destroyed.
And I needed to psychologically prepare myself for the year ahead.
And did New Zealand help?
New Zealand's great. I love it.
What did you like most?
Not doing a great deal.
Yeah.
Like we stayed in Wanaka, which is an hour kind of north of Queenstown, which is in central Otago, South Island in New Zealand.
South Island,
yeah.
Okay.
And that's where my dad's from.
Oh,
that region.
Homeland.
Yeah.
Was he loving it? Wait, did he go?
He went. Yeah.
Oh, he went. Okay, cool.
He loved, I think, living his childhood into my daughter.
Oh,
she's
cool.
almost 3. So it was a really great age for her. And she really enjoyed all the activities that we did. And you could really see on Dad how much he enjoyed.
Oh, that's nice.
Showing his life.
That's cool. That's very nice.
I think it was really good for my parents, but also my daughter loved it. But so we just had a house in Wanaka for 8 nights, and we just did like day trips around.
That's beautiful, right?
Beautiful, stunning.
So for anyone who's never been to New Zealand, go there. Gorgeous.
It's like a small version of Canada, I feel.
Oh yeah.
The South Island, just
mountains,
lakes.
Yeah.
Alpine.
Snow-capped.
Yeah. And but on a lower scale.
Did you go skiing?
No, it's summer, so there's a little bit of snow at the tops, but you wouldn't be able to ski on it.
But you could just ski from the very top down a little bit. All right, well...
But it was good. It was good. I love New Zealand.
That's good. Well, I'm glad you had fun.
So Kiwi listeners, thanks for having me.
Yes.
Yeah.
Yes. Do you reckon you're welcome back? Probably not.
Yeah. The guy in immigration made that clear.
Yes. As he went to stamp, it said never again. And you're like, I've never seen that stamp before. He said, we've only made it just for you.
And he said, choice bro.
Choice bro. Well, I'm good. Thanks for asking. I've been great. Everything's been good with me. Didn't get to go on holidays. Haven't been on holidays for many years. But no, I'm glad that you were able to take the time with your family for 10 days. 8. Yeah, well. All right. Well, that's good. It makes me feel great. Have you got
a trip planned?
No. We're going to go somewhere this year. We don't know where.
New Zealand.
Yeah, we might go to NZ. Since you said it was a great time.
It's close. Like 3-hour flight.
That's true.
And it's like a completely different environment.
Yeah, maybe because it is, but yeah, that's...
No, it's like it's almost like you go into the Northern Hemisphere.
Yeah.
Whereas if you fly anywhere in Australia, it's the same.
Well, in a way, but I suppose you're right. I mean,
except maybe Tasmania.
Tassie's great.
Yeah.
It's just always cold and windy. I can't handle that. So... I've been to Tassie many times. The food is amazing in Tasmania. Anyway, people aren't listening because they want to know about food in Tasmania. People are listening because they want to know about wound healing, Matt.
Right.
Don't they?
So we're getting straight into it?
Well, I think so.
Okay, nothing else?
Well, you know what I should probably do at the beginning of these episodes instead of the end is
say welcome.
Welcome. Everyone watching the YouTube channel, you can watch this episode, not just listen to it on the podcast, but you can watch it on our YouTube channel, Dr. Matt and Dr. Mike, where you get to see at least one beautiful face, and we will have images that pop up. So when we discuss things associated with wound healing, we're going to mention stages and phases and things that are happening, and we're going to have images that pop up. So this can sort of save you having to try and picture this in your mind's eye, what we're referring to. We'll have nice images that can demonstrate that. But if you want to contact us, every month we do an episode. It's not the mailbag episode. It's been confirmed that it's not called the mailbag episode. It's called Listener Mail. And this is where you can ask us questions. And
we're still waiting for a jingle, by the way.
Yeah. How many questions do you reckon we get or emails we get a week? We get dozens.
Quite a lot.
Probably get dozens a week. And we take what we think are, great questions, interesting questions, and also when
Feedback as well.
hey, if you want a higher likelihood of getting your question answered, tell us how great we are in the email, and we'll read that out and then we'll go to the question. You can send us an email, gubiosciences@gmail.com. Go to our website, drmattdrmike.com.au. There's the plug. It's all done. Let's jump into...
We don't have to do it at the end.
We don't, but I will.
Because we're exhausted by the end.
Yes.
I'm drained.
Really? You don't usually do much during the episode. I don't know why you would be drained.
Listening to you.
Yeah, okay. I was going to say your contribution is minimal. So
anyone's drained after listening to you.
Because I've got so much energy, I'm a powerhouse. I'm a knowledge cavity.
It's like spending 2 hours.
That's filled with knowledge,
it's like
not
spending
empty.
2 hours at a rubbish tip.
Really? Just surrounded by
flies. Stench. No one knows ibises.
People
except
do.
you're an ancient Egyptian.
Bin chickens, we call them here in Queensland. How do we...
Do you know some guy got arrested for eating one of them?
A restaurant got closed down for cooking them and saying it was duck. No joke.
It's not too far off that.
Would you eat it?
Well, I'm vegetarian, so...
Oh, there's your get out of jail free card.
Look.
There's your get out of ibis free card right
I
there.
don't necessarily see much difference. It's just seen as a taboo animal.
Right.
So really, I think once you embark upon eating animals, it would be hard to make an argument for which animals should be eaten and which shouldn't.
Okay. So you're saying, if you eat a cow, by extension, there's no reason why you shouldn't eat a cat.
Correct.
Okay.
Correct.
Right.
For me, like roadkill's roadkill. So
why is the cat roadkill?
Well, you see a plenty.
Now we're getting a bit of insight into your very
Do you
strange
want to hear
existence.
a childhood story?
Is it going to
It's going to involve cats.
Are our listeners going to switch off?
No, I don't think so, no. But I did learn some of the way that the world works. So I grew up in a town in New South Wales, close to a river.
Yep.
Went fishing one day. I don't know how old I was. Maybe I was late primary school.
Okay.
I finished fishing. I don't think I caught much. So I threw, I didn't even think about it at the time. I threw all the leftover bait on the road, which is actually a highway. So it was
threw it onto the road.
because I wanted to see it flattened, the bait, so the small fish. I thought this would be cool to throw it into the road and watch cars run over it.
And make them squished.
And see them squished. So I did that. I was like, that's cool. Didn't think anything of it. Next morning, there was like 3 dead cats on the road.
Oh, no.
Yeah.
Oh, no. Oh, man.
Yes.
That's your fault.
I don't like to think of it like that.
But you should. Because that is your fault. That's your fault. You baited them. You baited them
But
onto
it wasn't
the road.
my intent.
No, it wasn't. And you're a child.
That's
and
right.
it wasn't your intent to do that. I think what you've also likely done is we've probably lost a dozen people now because they see you
In a
as
different light.
cat killer.
That was my nickname in primary school.
Mine was the Zodiac Killer. For other reasons. No. All right. Well, I think we should move on. Yeah.
That's a good segue into wound healing.
Well, it's not. But we will push forward. Wound healing is today's topic. This is where you have some degree of damage to it's probably your skin predominantly that we refer to because...
Today, actually, I will infuse a number of, childhood stories like that in today,
God.
which will help to underpin the fundamentals of wound healing. But none of them will involve, I was going to say none will involve animals, but that's not true.
well,
At least one will.
Involved 3 so far.
Yeah.
So because your skin is the primary barrier separating the external from the internal environment, it's the most commonly injured tissue of the body.
Have you quantified that?
No, I haven't verified it, quantified it or anything, but my assumption would be it is.
Okay, so what you're saying here is the skin, from our body standpoint, it is the most exposed part of our body to the outside world.
Yes.
Incorrect.
Okay, wait. Because I was then going to clarify and say that most of our skin, particularly the external layer of the skin or layers, is made up of a tissue type called epithelia. And epithelia, of the 4 tissue types of the body, there's epithelia, there's connective, which we're going to talk about both today.
Yeah.
There's nervous and there's muscle, right? Now, epithelia tends to line structures of the body and create barriers between environments. And it's not just outside to inside like skin, but also between environments, for example, from the hollow ducts of the gastrointestinal tract.
But also ducts, so that's glands as well.
Yes. So my assumption would be, because they are the barriers separating out environments, they are going to be exposed to both internal and external stresses that would likely damage it. And therefore, I was going to clarify and say that the most damaged tissue of the body would have to be epithelial.
You'd think, oh, yes, no doubt.
Okay,
Yep.
There we go. So I win, full stop. What were you going to incorrectly correct me on?
Oh, I was just going to say, and a lot of students don't appreciate this, but probably the greatest surface area of the body that's exposed to the outside world is either your gastrointestinal tract
Yep.
or your respiratory tract.
Right. Or in your case, your fat head.
My scalp.
Your scalp. Yes. But does
Which you wouldn't think though, right? Intuitively, you would think there's no way. Because you look at, like I'm looking at you now and everything I can see is basically
Digestive.
skin.
Oh. But my point is that inside the gastrointestinal tract, that is epithelia,
Yeah,
just like
that's
the
right.
skin. And therefore, epithelia is the most
But I think you
damaged
said
tissue.
skin though.
I did say skin. Okay. Anyway, we're nearly 12 minutes into the episode.
We've learned a lot.
And
We've
we're
learned a lot.
talking semantics here.
So going to cellular physiology, for our 36 trillion cells to continue to function.
36 trillion human cells?
Yeah, good point.
Okay.
Good point. They need to continue a process called homeostasis.
Oh, yes.
So remain in a balance.
Oh, starting at the beginning, aren't
Yeah.
we?
Now, because they are exposed, now a lot of them are within the body, but that doesn't negate the fact
What?
that
The cells?
yeah.
Yeah.
So they're not exposed to the outside world. You know, some are, but many of them are internal, right? But that doesn't discount the fact that they are still exposed to stresses and potential injurious agents.
Yep.
So they need to adapt to these stresses and injurious agents to maintain homeostasis. And so this is generally referred to as the different methods of adaptation within the body.
All right.
So do you want to go through a couple of examples just of how cells can adapt to maintain that homeostatic?
So you're saying that, because everything needs to maintain a happy, healthy balance to keep you alive, that anything that's exposed to the environment, you can't really control. So it's constantly getting bombarded by things which might, and this might answer the question, but, chemical things, physical trauma, whatever it might be, radiation, temperature, these types of things will be stressors
Yes.
that we need to be able to, and when I say we, biologically need to be able to respond to mitigate the damage that it causes or to limit further damage that it causes
Yep.
to maintain homeostasis. All right. And so your question was, what are some of these stresses?
Yeah, and also it's the adaptation, the types of adaptations that
Okay.
these cells would take place to overcome these stresses and injurious agents.
Okay, so I would say that some of the stresses are some of the ones I just mentioned. So it could be chemical stresses. Those chemicals could be like acids and bases.
Okay, well,
right?
let's stick with that one then.
Okay.
So
So you don't want to go any more?
we'll start with there.
Oh, we're going to go through each one.
Just as, you think that's too much for today?
No, it's okay.
Okay. So as an example, the common example we would use in pathophysiology class when we're talking about chemical environmental change would be the esophagus.
Oh, yeah.
So this is the pipe from your mouth down to your stomach.
Yes.
And because it's usually just a conduit and it's just taken a bolus of food down with it, which I know you're going to say I don't chew, so mine's going to be...
Yeah, whole pizza.
That's right. So...
Which is strange because you get so many teeth. It's a wonder you don't chew.
Well, I didn't chew once. I just do one close and it's done equivalent to 10 chews for you. It's like a garbage compaction unit.
Oh, right. So your teeth don't tear or break or
Just flatten,
they just flatten. Right.
like hydraulic
It's a
system.
compressor.
That's right.
Right. I don't even hear that say that. Bzz, bzz,
That's right.
bzz, and then the food just falls down the back. I wouldn't even call yours an
in a
esophagus. I'd call
block.
yours a gullet.
In a block.
Just this cube. And you even see the cube as it moves down. Right.
Anyway, because it's a conduit and it's getting this bolus of food kind of thrown down through it, it probably wants a tissue that's more exposed to abrasions. So it probably wants to be a type of epithelium which is
Like skin-like.
skin-like, that's right. So stratified, so it can just keep regenerating itself.
Yeah.
But in some cases, some individuals will have a faulty sphincter in their stomach esophageal region.
Yep.
Okay?
I know what that's like.
Yep. So you're one of those people.
Faulty sphincter, they call me, which is the sequel to Faulty Towers.
And so acid would come up into the lower regions of your esophagus.
Yeah, because the
Okay.
stomach's dynamic. It folds in upon itself,
Yeah.
jackknives, flicks that acid up into the esophagus where it shouldn't be. The esophagus never shouldn't be experiencing acid. So it goes, what the hell's going on here? I'm not made of stomach cells to be
Yeah,
able to
that's right.
withstand this acid like the stomach can. I'm made up of this stratified squamous skin-like cells simply to protect physical abrasion, but not to protect me from chemical
That's right.
injurious agents. And then it changes, right?
Yeah, so this is a type of metaplasia, meta meaning different growth, but not disordered growth.
Plasia means growth.
Yeah, that's right. And so those lower cells in the bottom part of your esophagus would change form into more cuboidal-like cells to overcome the acid environment.
It's sort of, in a way, it's going, I need to become more like the stomach. The stomach's got these cuboidal columnar cells that can secrete stuff. I'll try my best. It can't do it, but it tries to do it.
That's right. So
and that change, anytime a cell changes, it increases its likelihood for introducing DNA. Anytime it replicates and changes,
that's right.
it can introduce mutations, which increases its likelihood of becoming cancerous.
Yeah. So this is this is called metaplasia, and so it's changed forms to overcome this stimuli or injurious agent.
Yeah.
And so this is just an example of how cells are trying to maintain homeostasis when you're throwing potentially damaging things to it. But it can also be physiological. So that's what you would say is pathological.
Mm-hmm.
But you could also give an example of physiological adaptation. So if you were, I don't know, to do a cardiovascular exercise at a higher level over extended periods of time, you're needing a lot of blood to your exercising muscle, which means you also need a high degree of blood pressure. And that, to do that, you have to have a fairly well-functioning heart. Now, the heart needs to push a lot of blood, but also push a lot of blood against that higher pressure. So the heart, let's just say an athlete state, would develop against that stress, and we're specifically talking about the cardiomyocytes here, to become bigger and stronger to generate more force.
Yep.
And this is what we call a hypertrophy. But this is what you would state as physiological, so it's probably still a good thing. But if you were to do the same thing but in a pathological state, like instead of working in an exercise context, but you're now working in just a chronic high blood pressure state, the heart would still do a similar thing. It would hypertrophied, but it would be more of a negative type of hypertrophy, which would be more pathological. Even though the cells are getting bigger, the dynamics of how they're doing so is not so good.
Yeah.
And so this is just some examples of what cells are trying to do when they are either stressed or they are exposed to injurious agents. Yeah.
So in today's case with wound healing, if we refer to a cut, for example, are we going now into a cut to the skin, for example?
Yeah, so with wound healing, you've really caused now damage or death of tissue.
Yeah.
And the point of wound healing is...
Let me guess.
Okay.
Heal the wound.
Yeah.
Okay.
So what you're actually trying to do at that tissue level, and what example did you give at a skin?
A cut.
So a cut.
Yeah, so
How?
I grab a butter knife.
I don't think a butter knife does a great deal of cutting.
I know, but...
Say a steak knife.
fine. I grab a bread knife and I look at your arm and go, that looks not bloody enough, and I start hacking into your arm.
Okay, all right.
Not too deep,
Brutal, but
one hack.
brutal
one single
example.
cut.
Brutal example.
Yeah.
But what's happened here is you've opened up the tissue. Let's say it hasn't got down to the muscle level. It's just got through the epidermis, dermis,
Hard to hit muscle when it's not there, mate.
and you've exposed it to the outside world. Now, the whole function of wound healing here, because you want to restate the tissue, when you bring it back to its normal self,
Yeah.
right?
I've introduced an opening.
You want
Let's close it back
So
up
what
again.
wound healing is trying to do here is restore the tissue architecture and bring back the function of the skin in that area.
Yep.
Right? And so the way it would do this is through a number of stages.
What are these stages?
Well, the first stage is generally, the most immediate concern here is loss of blood.
Right.
So you really need to stop that and get a plug in place because you don't want to lose 7 litres of your blood.
No.
Because then you're not going to
Especially when you've only got 6.
So you're not going to be functional anymore if you've lost that amount of blood. So the first step is to stop the bleeding, which
Hemostasis.
is hemostasis.
All right. Then what?
Then pretty much, I would say concurrent to
I would
that
say 2 as well.
is inflammation.
Yeah.
So anytime you have cell injury, you're going to result in the cells dying, but also the body's way of cleaning up the mess is to bring in a process called inflammation.
Yep.
And this is really a combination of bringing more blood to the area, flooding it with fluid, plasma fluid, and bringing in important cells, immune cells, to clean up the area to prepare it for healing.
Perfect.
So
we've got blood stopping, then inflammation, then what?
and then
So we've set the scene now.
yeah, then you want to start the repair process.
Okay.
And you partly doing this is you need to proliferate all the cells that you think are most important for the wound healing
Right.
process to begin.
Okay. So you need to grab a bunch of cells that we know are required to repair and regenerate.
Yep.
Okay. We go through those.
We will.
So that's proliferation. So we need to proliferate those cells. And then the final stage.
Is remodeling.
Okay. And so once these cells are proliferated, what do you mean between proliferation and remodeling?
They will
What's the
do
difference?
their fix up. They will fix it up, and then they will get pulled away or killed or slightly altered just to allow the tissue to kind of go back to its original state.
So it's sort of like the proliferation stage is sort of like bringing in a bunch of labourers
Yeah.
to start laying the bricks, laying the pipes, laying it all in. And then once it's done, the labourers need to bugger off.
Yeah. I was thinking of something similar, but additional to that, you know how when you have like a house reno,
Yeah.
or maybe even more extent to that, you bring in the scaffold in,
Oh, yeah.
and it's all to help with the process of
Yes.
fixing or building.
Then you've got to pull it away.
And then you got to pull it all away.
Yeah. Or like when you buy like a brand new iPad or TV, it's got the plastic casings
Yeah.
around it. They sort of got to pull off. That was part of the process to keep it.
Yeah.
Okay, cool. So we've got hemostasis, inflammation, proliferation, and then maturation or remodeling.
Yep.
So they're the 4 stages.
Yep.
Okay, so
Now, we're going to mostly use that in the example of skin, right? When we go through those depths.
yes, but I wanted to ask a question, and you may not want to talk about it.
No,
now.
I think it's.
But
this is the time to do it.
Okay, so you were saying that once you've stopped the bleeding and inflammation has occurred, you need to choose a certain group of cells to proliferate, right? So that you can. So if it's skin, you need to choose the cells that allow for skin to regenerate, and basically tell them it's time to regenerate. But that particular type of process only really happens when you've got a population of stem cells available to you, such as in the skin, because the skin's always making new skin cells, right? New keratinocytes and so forth, and new epithelial cells. So they've got a population of stem cells available. So we would call that a labile tissue. It's got the capacity to continually regenerate
Yep.
and make new tissue,
Yep.
right? So things that are constant, parts of the body constantly doing this are skin and the digestive tract.
Yeah, I think epithelium, just going back to what you said at the start.
Good point, epithelium. But there's other tissues that really don't have this nice stem cell population available. They've got cells that can undergo a particular lineage of development, but they don't have the capacity to really create what's always needed at the time. And so these cells tend to be termed stable cells. And the liver, for example, we were having a chat before and we were talking about, well, a good friend of ours had to have a big chunk of his liver taken out, right?
So the context there is there were some tumours in his liver, and the oncologist and probably other specialists thought that by removing sections of the liver, you'll take the tumours out with it, and then the liver has the capacity to then grow back to its original state.
Yes, but it doesn't have the capacity to grow back to its original state in the same way that skin cells do and the epithelia does. So the liver is what we term a stable tissue. And so it doesn't have these stem cells. It's got mature differentiated cells which can continue to grow, develop and divide and basically undergo hyperplasia. So just produce more of the same cell types.
But it's a fairly remarkable process though.
It's amazing.
And how it can do that is phenomenal, really.
Well, most tissues of the body, it's important for us to understand because we always think about, for example, a lizard's tail comes off and they grow another tail. Right? Why can't we lose an arm and grow an arm back?
Yeah.
That sounds like it would be a great thing to have evolved. But the downside of having cells that can regenerate so easily and then differentiate so easily is the likelihood of them just becoming cancerous.
Right.
And so
what you're saying is if you look at anything you can't really say before, but let's say evolutionarily before mammals. So reptiles, I'm not sure about birds, but particularly amphibians. If you were to remove, just like we spoke about the liver, if you were to remove tail, body parts, it has the potential to regrow those completely.
Yes.
But mammals have lost that ability.
Yes.
And your theory is that for some reason we've deselected for that. And the possibility is that because of the risk of the cells being so mitotically active, they could get faults in it.
That's my primary hypothesis. I would say that we would have sacrificed that for something else, which may have been, because think about how energy intensive it would be to regrow a limb, right? We probably put most of that energy into our brain and being able to hunt and survive and so forth. My thought is that.
But we would have lost that long before we got to that level of brain development.
Absolutely. But yes, that's my hypothesis. It might not be true, but anyway, so we've got labile tissue, like epithelia.
The one hypothesis that I saw with that was just the predation pressures within that type of organism. They've got a lot more nastier things that are coming after them.
Yeah.
And so they've retained that function, whereas mammals maybe have a safer.
That's true. How often do we lose a limb? Compare that to other organisms who probably lose it far more often and therefore require it for survival. So we've got labile tissue, which is like the epithelia, where there's stem cells that can regenerate new cell types. Then you've got stable, which is like the liver, where it's got an already differentiated mature cell line, but can make more of itself, like the hepatocyte. And then finally, you've got the permanent cells. So these are ones that when you damage, their ability to regenerate is very, very poor, and they're probably more likely to form scar tissue as opposed to a functional cell population.
Yeah, and that's important to note here. When we refer to wound healing or tissue repair, there's only real two methods of how it can do this. It's either regeneration or scar tissue formation.
That's right. Yeah.
Because the whole point of both is just to fill the wound back up so the architecture has been restored to the best it can, and hopefully the function comes back. But when we look at the permanent as an example, just move into our research, I mean, I know you've gone a bit of a way from this.
Your research.
But you did spinal cord stuff. So when you look at a nerve injury, because your example of permanent could be a neuron, right?
Yes. Yeah. Well, let's just give some examples and then.
Okay.
So some cell types that or tissue types where regeneration is limited, and it's called permanent: skeletal muscle, neurons, cardiac muscle, cartilage.
Yes. Yeah.
So you're talking about neurons as an example.
Yeah. So neurons is a good example of it. If you damage them and they're lost, there's no way you can get them back.
Yeah.
Now that's not entirely true. Now we've learned a lot more that isn't entirely the case. But if you were to look at a nerve injury like a spinal cord injury versus a peripheral nerve injury, what you'll find as a difference between the two is with a spinal cord injury, after the initial insult, what happens is all these processes that we spoke about, you're going to have a degree of hemostasis, so you're going to have bleeding into that area because it's probably going to be either a laceration or what's a penetrating wound, or it could be a contusion like a compression or a ripping kind of. But that's going to result in blood vessel bleeding. So you're going to have hemostasis in the area, inflammation, proliferation. So cells are going to come into that area to try and repair it. But unfortunately, in the spinal cord case or the brain case, certain glial cells will come in, like astrocytes, like microglia, and they do the latter process of scar tissue formation. And what that does is put a whole lot of scar tissue between the two ends of the neurons that are broken, and they have no ability to reconnect because you've got big chunks of scar tissue in there. So that means, generally speaking, you've lost the ability of using those neurons now.
Yeah.
Now, if you can compare it to the same types of cells, but in your, let's just say your limbs. So instead of spinal cord injury, you've had, let's say, an upper limb injury where you've lacerated your upper arm and you've cut through the median nerve, for instance.
You're still talking neurons.
Still neurons.
Just not central nervous system neurons. You're talking peripheral nervous
So you've sliced through it. The two ends have been cut apart. But the cells, same thing, hemostasis, first step, inflammation. But what's happening here is the supportive cells do a different job. So the Schwann cells in this case that are myelinating the nerves detach off and they start to clean up the environment, as do macrophages. But the neurons can re-sprout and there's no scarring at this point that's impeding it. And as long as you can get the two ends together close enough, there shouldn't be a reason why they can't grow back down and then regenerate. So there is the and this is part of the research that's been done in our lab with spinal cord injury, is if we introduce different cell types into that area that may not cause the scar tissue but help the regeneration, that they may lead to a better outcome. Yeah,
that's right. So they're the three different types of tissue regeneration: labile, stable, and permanent. We need to jump into wound healing, Matty.
Can I just say one interesting thing?
Yes.
So with the scar tissue, not only is that for the tissue type, so permanent tissue, but it's also to do with the extensiveness of the injury.
Oh, right.
So you can still have scar tissue formation if you had a really extensive skin injury.
Yeah.
So if you were to take off huge amounts of skin instead of the bread knife, let's not use a bread knife example, let's just say a scalpel incision. It's very clean. You can get the two edges close together. The repair is going to be pretty good, that it will go back to its original state. But if you lost huge amounts of tissue, it doesn't have the capacity to grow back the same way.
So you're saying that if right now I had a scalpel and I just did one slice into you, because it's a nice, neat slice, those edges can come back together. The healing is easier.
That's right.
But if I were to take
which would be the regenerative process that we spoke about.
But if I were to take the scalpel and then start hacking chunks out of you, that obviously there's not neat edges for it to come back together. The regeneration is going to be different.
Yeah, maybe if you took a whole strip of skin away. Like skinned my arm.
What if? Okay, so let's.
I'm going to give you an example. I'm going to give you three examples later, and I want you to classify them in terms of how do we rate wound injury and repair by intentions.
Okay,
but we'll get to that.
Well, let's go to this point, intention, right?
But I'm almost there. Can I just come back?
Sure.
So So what you would try to do there is fill the wound up with scar to try to lay down the platform for the cells that can regenerate to fill it up and then hopefully do as best of the healing as it can. But in some cases, if you've got ongoing injurious agents and you don't get rid of it, the tissue will actually revert to a scar tissue type of regeneration.
What's the point of wasting my time and energy putting in functional cells here when it's just going to continually get destroyed? Let's just chuck in a bunch of bricks.
So here's the example again. So liver, as you said, if you were to slice, I think it said you could take 90% of the liver away. 90 away. Wow. Leave 10% of the liver. Yeah. It will grow back to its original size.
Jeez.
All right? So that's a nice clean cut.
Yeah.
Now, if you were to still bombard the liver, but in this case you're bombarding it with
alcohol.
Okay, well, sure. We'll use that as an example.
That's a toxin.
That's a negative stimuli.
Yep.
You bombard it for years, decades, right? Mm-hmm. It's this ongoing inflammation process where the inflammation is releasing ongoing chemicals and growth factors, which instead of telling the hepatocytes, hey, just grow back and lay down your original tissue, it's stimulating the fibroblasts. And the fibroblasts go, oh, I keep getting stimulated here. These are the bricklayers. I'm just going to keep laying down a heap of bricks. And what your liver's left with is just full of scar tissue.
That's right.
And then you don't have a functional liver anymore.
And what's that called?
Well, that's cirrhosis.
Okay.
But you could have that in multiple locations with chronic inflammation. And this is the problem with having these inflammatory states over long periods of time.
That's right.
Another good example is blood vessels. You know, if you were to cut your blood vessel acutely, it would repair really well. But if you were to chronically inflame it, and a good example of this is if you expose it to high blood pressure or smoking,
too much glucose,
or diabetes,
such as diabetes,
it causes them to be inflamed over long periods of time, and it tells the tissue stay in this chronic inflamed state, and it lays down tissue. But in atherosclerosis is a combination of fat will keep building up in it and fibrotic tissue, which is atherosclerosis, and a huge risk for heart and stroke and peripheral vascular diseases.
Yep.
So that's just another example of how scar tissue can also go down that path just with ongoing negative stimuli.
Yeah.
Now we go to intention.
All right. So what do we mean by intention?
I don't actually know what the term means.
I think it's just its intention to heal.
Yeah, okay.
Right. So obviously when we have a look at, and we're focusing on skin here, right? Because it's going to be the predominant, I think from now on, we're probably going to be focusing mostly on skin.
Yeah.
So if, like we said, we were to cut Matt with a scalpel.
Can I give you the 3 examples? Or you want to define it first?
Well, I want to define each of the 3, right? Just the what intention is. So if I cut Matt finally with a scalpel, then you've got 2 clean edges that can easily come together, and that means that heals by primary intention. So the wound edges come together. Now, whether that comes together naturally, quote unquote, or whether it's sewn together, that's still
glued,
or glued,
stapled.
Yep, still primary intention.
Yeah.
Or you can have secondary intention where I've cut a chunk out of you, for example, and the edges can't neatly come together. So you just need to fill the void, fill the gap, right? So that's secondary intention. And I won't give any examples here because you're going to give examples. And then tertiary intention is different to both. Tertiary intention is where you've got something in the wound that might be bacterial or parasitic or it's just, maybe it's a dirty wound, right? Maybe there's something about the wound where you don't want to close it up straight away. You want to keep it open for a period of time. And then once it's cleaned or has undergone a particular process, you can then close the wound. And that can then, so tertiary intention can then close either through primary intention if you sew it up or through secondary intention if you leave it to close by itself and fill the gap.
Sounds good.
Is that cool?
Cool.
All right, give the examples and we'll see if our dear listener can tell us.
All right, so these are 3 stories within my life that's happened.
Great.
I think early high school, I was fishing.
Yeah.
On a rock wall. So these are fairly common in Australia.
You like going fishing, don't you?
That's right. It's also fishing. So I was fishing on a rock wall.
Yep.
My parents and grandparents were having a picnic. I found that quite boring, so I went fishing.
Yep.
So the rock wall is just like these big boulders that jut out
People
to the sea.
know what rocks are, so that's fine, yeah.
So I was fishing there, and for whatever reason, I slipped, fell off the rock wall into the water.
Yeah.
So it was high, so roof height. So what's that?
Right.
3 meters?
Yeah.
Into the water. As I was going into the water, scraped one side of my body all along oysters.
That makes me feel sick.
So because you know when you have an event like this that's kind of shocking but adrenaline inducing, you don't really
Feel it.
or you don't really comprehend
How
what's
bad
happened.
It could be. Yeah.
You kind of, it's just the shock of it all.
Yeah.
So I kind of just fell in, just at, obviously you felt like I've hit a number of rocks on the way down, and then I've just I'm completely soaked. So I got myself out of the water, got my rod back, walked back to my mum, dad, and didn't think much of it. And then like their mum scolded me because it's like, I didn't bring you clothes, you idiot. And then everyone realizes that half of my body is like ripped apart by oysters. So that's story one.
Okay.
Story two.
Yep.
Probably also a similar age, but this time I was in school.
Yep.
And I was in metalwork.
Yep.
Okay.
And you decide to pull your fishing rod out.
So no, it's no fishing this time.
Okay.
So I was doing metalwork, and I was walking back with a chunk of something, metal, back to do grinding or something.
Right.
And all I remember, and in those days, we wore shorts to work to school, right?
Correct.
Not long pants.
No.
So walking back, and I just felt that I scraped myself against the rack of all the scrap metal
Yeah.
along my side of my calf.
Jeez.
Honestly, I didn't think of anything else.
Yeah.
Kept on going, and then
Your socks are wet.
and then I'm like doing some grinding or something, and then I felt a trickle down to my sock,
Yeah.
and I had a student next to me, and he's like, "What the hell did you do?" And I looked down, and honestly, I had a wound that was like
Really?
the size like a banana could fit in there.
Whoa.
And I went and showed my teacher because it wasn't painful.
Whoa.
And my teacher almost fainted.
As in it had opened up that much?
really opened up, like the size of a banana.
How deep?
Deep.
Whoa.
And so,
Whoa.
and it honestly didn't. But you know when you cut steel, you know when
This
they cut
episode is going to make everybody turn off.
when you cut steel,
Yeah.
it gets that barb, that sharp. It was that.
Yeah. Oh, Jesus.
And so
Boy.
the ambulance came, and then I had to go to ED. Dad had to get called from work, and he's like, "Wow, that's impressive."
Jesus.
That's story two.
Wow. Okay.
Story three.
Yeah.
So this one involves my wife now. We
what did you
just
do?
got married, and we went on a honeymoon to Thailand.
Yeah.
And this
And you went fishing.
no, close though.
Okay.
This time we went on like a adventure kind of trip where it was like 3 different main activities for 2 weeks. So it was Thailand. So it involved a hiking component,
Right.
a cycling component, and a kayaking component.
Okay.
So it was like an adventure kind of holiday. And so we were on the kayaking part. So it was down near Port Krabi, which is near, where does all Aussies go in Thailand?
Oh,
Phuket.
Phuket. Yeah, Phuket.
So it's down near there.
Yep.
Now, because we were on a kind of tour, they took us across to an island for the night, and it was the island where they did the beach.
Oh,
Remember with
Leonardo DiCaprio.
it was that island
Yeah.
where they shot it.
Good film.
So
I've never read the book. Have you read the book?
no.
Okay.
After all the boats left
Yep.
for the afternoon, we had the island to ourselves.
Oh, wow.
And so the group, which wasn't a big group, maybe 14 people,
Wow.
we were all like just playing in the water.
So you're on the island.
Yeah, on the island.
Right.
Yeah.
And
But the way that the islands are there is
Yep.
like the beach, the sandy part's very
wide.
opposite,
narrow. Okay, yeah.
and it just goes to jungle.
Right. Oh, sorry. I thought, okay. Yep.
And so we were all playing like frisbee in the water, and then there was one British guy who was like sunbaking on the sand.
Yeah.
And we're playing, and then all of a sudden I look up, and there's this Komodo dragon.
Oh.
The size of, I don't know how, like not a crocodile, but it's
Wow.
massive. Big as him.
Like 6 foot.
Yeah.
Oh. Near him?
Right next to him.
Oh, and he doesn't know.
He's head down, and we're all screaming.
Oh,
And then he looked up and
Jesus.
eye to eye with it, and then ran,
I didn't get him.
and it bit him.
Oh, no way.
And so it bit him in the calf.
Oh, no way. And there's,
So
how did you get him?
So
'Cause
that's
they've got venom.
So
in
there's
there.
the 3 stories.
Aren't they venomous?
We'll get to that. There's 3.
Jeez. All
So-
right. Okay.
Rate them.
All right. Well, 10 out of 10. As stories. Okay. First one, falling off the wall
Yeah.
with the oysters. I would say that the extent of the lacerations are likely to be, I mean, you could argue a tertiary intention because there might be bacteria present from the oysters, but I would say that it would be secondary intention there because there's so many uneven cuts and
Yeah.
grazes. I mean, you've sort of you haven't just like neatly cut yourself from the edges of the oysters, but you will have grazed yourself significantly down the wall. So there wouldn't be super clean edges.
Yeah, I literally got no stitches from that.
Yeah.
I do
But it would have
remember.
taken ages to heal.
I do
see.
remember the GP had to put like local anaesthetic into every hole, and then
Like eyes, nose, bum,
No.
ear.
on that side of my body,
Oh, okay.
and had to kind of scrape it out like with a brush because there was shells in it.
All right.
So and then
You're making me feel sick.
dressed it.
Right.
But I do think
a
there's
tuxedo with a
one
top hat.
here that I think there's still shell in it.
Really?
Yeah.
Wow.
Yeah. But it's you're right. Second intention, that one.
Okay. Probably tertiary, then secondary intention there. I would say
He
that.
didn't keep it open.
Okay. Oh, okay. All right. So secondary. Then you've got the disgusting one where you cut your calf open that you could, for whatever reason, decided to describe it by sticking a banana in.
That was the reference scale.
That is enormous.
Yeah, it is big.
you still have a
Honestly,
scar on
it
your leg?
shocked me. Yeah, I do.
Wow. I'm surprised you didn't. Where about on the side or on the back? Was
The
it near
side.
your
It was like
popliteal?
no, it was the side. So it was like the fibular compartment.
You
of
were
the
so
perineum.
lucky. You were so lucky you could have bled out. That's obviously primary intention.
Yeah.
They would have just. How many stitches you get from that?
Can't remember. I think it was in 20s, but a lot of that was internal. So like
Jeez.
muscle as well as skin.
Did it affect the way you moved?
No,
No.
not at all.
Oh, it looks like it has now. And then finally, the Komodo dragon one. Well, now this is horrendous. So that bite, I know that
It's not poison.
it's not poison.
It's bacteria.
It's bacteria.
Because it's got rotten
So
flesh.
is it venom or is venom injected?
No, it's from the bacteria, my understanding.
Okay.
But also my understanding that it uses that as a method of killing. So
Yes,
it
that's what I've
just
heard.
bites things
That's
and
why I
then
thought it was
lets it die.
That's why I thought it was a venom because in
Yeah.
a way you could argue it's injected.
I think
through
it's
the
probably
skin
just
through a puncture wound.
exotoxin of the rotting bacteria.
So I would assume that's tertiary intention.
That's
They would have had
tertiary.
to clean it, probably cut him further maybe, and
Okay.
open it.
So of that story, 99% of it's true. He didn't get bitten. But
Oh,
I
okay.
just threw that part in.
Lucky. Oh my god.
But everything else was true. Like honestly,
Oh, that would have been.
you should have
frightening.
seen his face. like
But they're probably used to being fed. Maybe they're very used to.
it was so big.
Mate, I would have.
Like I wish I recorded that because the face expression that he had.
I would have pooped in my underpants. Honestly, that is frightening. All right. So did I get the intention correct?
Yes, well done.
Thank you. I think just looking at time, we need to move on to actual wound healing
Yeah,
itself. So we spoke about the steps: hemostasis, inflammation, proliferation, and remodeling. So let's just go through those one by one.
Yep.
I think let's talk about maybe just the primary intention.
Yep.
So a nice clean cut, but this cut is of the skin. Let's say the cut you got on your leg, but maybe not going as deep as the muscle. Let's just say it goes through the epidermis into the connective tissue, so the underlying dermal region, and into the blood and into the vascular supply. Are you okay with that? Which is probably where most of these injuries occur. So you've got first this penetrating wound that has damaged these tissues. Like you said, the very first thing that needs to happen is hemostasis. So hemo means blood, stasis means stopping. So we're going to stop the blood. Now, the body, luckily for us, does this through a 3-step process, which is pretty efficient at doing it unless you've got significant damage, right? So the first step of hemostasis is there's 3. First step is vascular spasm. So when you've damaged a blood vessel, you've damaged the endothelia, which is the epithelia of the vascular supply. And you've also damaged nerves around that area and nerves that innervate the blood vessel itself. So you're going to have this spasm that occurs at the blood vessel. This spasm is reflexive from direct damage to the blood vessel, in which the blood vessel narrows its diameter. But it also will constrict because it releases a number of chemicals, right, at the site. So its purpose here is to simply just, in the very first instance, as soon as possible, limit the blood going through that damaged vessel. That's the first step, right? Then
and we're talking small blood vessels here. We're not talking about arteries. We're just talking about capillary beds, right?
That's right. Capillary beds.
Maybe smaller arterioles.
Yeah. Now, the next step after the vascular spasm is what's called the platelet plug. Now, when you damage endothelia, because endothelia is epithelia and all epithelia sit on connective tissue, most connective tissues, particularly at skin and where the vascular supply is and everything, there's heaps of collagen, right? We're going to get to collagen again later because it's very important in the remodeling and proliferation stage. But when you've damaged endothelia and connective tissue, you've now got exposed collagen, and it's exposed to the internal blood vessel because the whole thing's damaged, right? Yep. Now, the thing is, collagen's negatively charged, and so are platelets, which are these cell fragments, right, from megakaryocytes. They're just these fragmented cells flowing through. They're negatively charged as well. And so the thing is that the great thing about collagen, though, is while it may be negatively charged, it's sticky. That's a good thing. And as a platelet comes past, it can stick to it. But the other thing is that when you damage endothelia, it releases this factor called von Willebrand factor, right? And von Willebrand factor is like a tether. It binds to the negative collagen, it binds to the negative platelet, and facilitates them coming together.
Right.
And then once the von Willebrand factor does this, it will stimulate platelets to release more von Willebrand factor, which stimulates...
so platelets do it.
Yeah, platelets. So both platelets and endothelia can release von Willebrand factor, and it pulls it all together. So what we end up getting is this...
So does it also do thromboxane?
Thromboxane A2, yep. That's involved as well.
Yeah.
Yeah, which is also involved. So thromboxane A2 is also involved in the clotting cascade, but also involved in the vascular spasm side of things, which is a prostaglandin. And we'll get to prostaglandins in inflammation as well. So you've got, because of von Willebrand factor and the exposed collagen, it's pulling collagen and platelets together, leads to positive feedback, which leads to more platelets and collagen coming together. And ultimately it forms this platelet plug. Not a clot, but simply a plug that's present. Now, the great thing is this further limits blood leaving. And then finally, the third stage of hemostasis is this extensive clotting cascade. So we're not going to go through the clotting cascade, but what we will say is that when you have damaged endothelia and when you have platelets that have bound in the plug itself, you have a number of enzymes and chemicals that are released that triggers a cascade of events that result in inactive proteins to become active. And these are the proteins involved in clotting.
So would you say rather than inactive, soluble, insoluble here?
Yes, you could, but not all of them are fibrin-like.
Okay.
And so the solubility is really only important when it comes to the fibrin-like.
Okay. But that's the end product you want to produce, right?
Yes. So at the end of this entire... Because there's actually 2 clotting cascades that come together, right? An intrinsic and an extrinsic. Right. They're both activated in this type of damage. So it doesn't matter which one we're referring to here. They both coalesce at factor 10, and that will ultimately coalesce in turning fibrinogen into fibrin, And fibrinogen and pretty much all of these clotting factors as well are produced in the liver. And this is important because liver damage can limit clotting ability, right? And so once you've got the fibrinogen turned to fibrin, the fibrin will form a meshwork, and it basically weaves between the platelets. And
reinforces it.
Right? Now, none of that can happen without calcium and vitamin K. They're two very important points just to add on top. If you don't have calcium and vitamin K, none of this is happening, right? So now we've got the clot that's formed. So the clot itself is like a Band-Aid now that's sitting, it's like a natural Band-Aid that your body's produced that's sitting over the top of the wound.
And that will include this, what will become the scab as well.
That's right. So we don't have a scab yet, just a clot, and this clot's made up of platelets and fibrin.
And we're talking this process, this hemostasis is probably in the scale of hours.
That's right. Yeah, that's right. Hours. Now, concurrently, so now we've ticked off stopping the blood, right? We've got hemostasis has occurred. Like you said, simultaneously, inflammation.
Can I just say one thing here?
Yes.
Because we've got those 4 stages, what I'd like to add here is there are factors that are being released chemically that will code for things to happen. And it's almost like each step then codes for the next one to start.
Yeah.
So in the the hemostasis phase, where you got platelets that are activated and they're coming in to plug it, they are releasing certain factors that then are initiating the next step to happen, which is the inflammatory start.
Yeah.
So you are working in the hour scale to get the wound plugged up with this clot.
Yeah.
And then all the chemicals that are involved in regulating that clot to happen brings on the next step.
That's right.
Which is inflammation.
So the thing about inflammation is that, in the hemostasis phase, you've got vascular spasm, limiting the amount of blood going to the area. But now hopefully we've formed a plug, or at least a clot, or we've formed a clot, at least a plug, right? And now, because of the chemicals that are released at the site, right, which include things like serotonin, prostaglandins, nitric oxide, endothelin, all of these chemicals that are released can stimulate the blood vessel to dilate at this area. And you might think, wait a minute, why do we now want more blood to go to the area? This is because inflammation is there to help facilitate the cleanup and preparation for healing. And so during this stage, those chemicals, like I said, prostaglandins and so forth, not only vasodilate, but increase the permeability of that blood vessel so that all of the components of our blood that are coming past, i.e. white blood cells in this case, they now come to this area in higher abundance, but also can slip through the little holes that have been produced through the vasodilation and increased vascular permeability to migrate to the area of damage.
And they're following just a chemical gradient.
Yeah, chemotaxis is the term.
Of where this injury is. So they don't really know where to go, but they have this kind of scent to follow, which is taking them right to the point of where that injury has occurred.
And the very first cell type that will fly in from inflammation is?
Neutrophils.
Neutrophils. So if you think of the white blood cells, you've got neutrophils, lymphocytes, monocytes, eosinophils, and basophils. And that's the order from most abundant to least abundant. And you can remember that with never let monkeys eat bananas, right? And so the neutrophils are the most abundant white blood cell, but they're also the first to come in to fight
within acute inflammation.
Acute inflammation. So what the neutrophils do is they're phagocytic. So that means they like to eat. They ingest things. So they help to destroy bacteria and viruses and anything that's there that shouldn't be there, start to gobble things up. And then they die and they start to basically they'll die off and form part of that clot, change its colour a little bit, turning into
Pussy.
a scab. Make it look more pussy, and that's part of the scab. That's then formed. But second to neutrophils, what's the next cell type that's called in?
Macrophages.
Which originate as?
Monocytes.
Monocytes. So when floating through the blood, they're monocytes, but once they start to jump into the tissue, they become the macrophages, which are also phagocytic, but macrophages are more specific. They're big eaters. They can take these products. They can present some of the products on the surface to call in more things. But at the end of the day, their purpose in inflammation, and this is one of the primary purposes of inflammation in this setting, is to clear the debris, to digest dead or damaged cells, and to
signal for the next process.
Signal for the next process.
And so this goes again, the inflammatory process is now kind of sending the signal to the next point to say, all right, we've done the cleanup, we've cleared it all. So it's again going to the building analogy.
Yeah.
You've kind of done the knockdown or the demolition part.
Yeah.
And now you're bringing in the builders.
That's right.
Or the tradies who are going to do the reconstruction.
Yes. And so this is where we now have proliferation. It's like, okay, guys, we've got...
So macrophage is doing all this.
Well,
it's like kind of like, it's in a way, I know we don't usually use this in terms of in the immune system, but in a way it's kind of like the site manager. It's doing all the signaling and telling who to come where and do what.
Yeah. And so now once we've, we waited 6 months for the tradies to demolish the house and clean it up. But for some reason they come in and say, all right, boys, let's get it done in 2 weeks as fast as possible.
So inflammation, we're talking days.
We're talking days.
The clot formation was hours. Now we're moving to days in the inflammation.
Yep.
And now we're moving to proliferation.
That's right. And so proliferation is a really broad umbrella term referring to a number of different things that are happening.
Well, if you think about it, what's everything you want to proliferate in this building site?
Exactly. So you need new skin cells to proliferate, so new epithelial cells or keratinocytes.
So what would you call that process?
Epithelialization. Re-epithelialization.
Yes.
Can you say it?
No, that's why I asked you to do it.
Okay. So you've got re-epithelialization. You've also going to you need more blood vessels, right? Because if it's damaged, and you're starting to grow new tissue, well, you need blood vessels to help infiltrate that area to feed it. We need to feed it. You need to give it oxygen, nutrients. Basically, it's like when you've got the what's the lunch truck that comes in, right? At Smoko, this might be an Aussie thing, but you got the lunch truck coming past. So that's angiogenesis, the production of new blood vessels.
So what's the difference between vasculogenesis and angiogenesis? But in this case, it's angiogenesis.
Okay. Do you know the answer?
I do.
Okay. So I'm just working on first principles here. I would say angiogenesis is infiltration of new blood vessels into tissues that probably didn't have blood vessels previously, so paving new pathways. And vasculogenesis is probably the repair of existing blood vessels or pathways. Am I wrong?
Wrong.
Damn it.
So vasculogenesis is the creation completely of new blood vessels.
Right.
Whereas angiogenesis is the branching off of an existing vessel into an area that needs blood vessels. So
how do you even do vasculogenesis?
Well, a lot of that would be embryologically, where you're producing new blood vessels to begin with, and they are then the mainstay.
So it's a trick question because you asked me a question about embryogenesis, which I know Sweet FA about. So thank you for that.
But angiogenesis is essentially through a lot of those signals that the macrophages are releasing. It's almost like
bush bashing.
Well, I was going to say like...
Is that another term? We're using too many Australian terms.
Australianisms.
Yeah.
So almost like roots growing from a tree that's growing towards something that the stimulus. And so from a blood vessel that's nearby, it kind of breaks it, so ruptures it, and it starts to grow endothelial tissue towards that stimuli.
Yeah.
And that would be like a vascular growth factor that would do that.
So correct me if I'm wrong, but this proliferation phase, you've got re-epithelialization, which is basically the new cells for the skin that you need to regenerate. Angiogenesis, which is new blood vessels and vascular supply. And then you've got granulation, which is part of this process. But is granulation simply these two things happening together?
But you also have to lay down the
connective tissue,
the scaffolding.
Right. And that's granulation.
Yeah. And that, at the building site, that would be bringing the scaffold around the house so all the tradies can work on, but also the things in the house that makes it more efficient for them to do their job.
So they're the three types of proliferation?
Yeah.
Granulation, re-epithelialization, and angiogenesis.
What was the other one? What was the first one you said?
Let's say re-epithelialization, angiogenesis, and granulation.
Yeah, and granulation is going to be, collagen synthesis, but also extracellular matrix.
Okay.
Which is just the ground substance that this is all happening in. So collagen's more like the strength of it.
Yeah.
And the ground substance is just the environment that it's all living in. So it could be gelatin-like,
Yeah.
jelly-like, whatever you call that.
Well, that's a good point to make, right? Because when we think about, let's take skin, right? Let's take the epithelial layer of skin, right? That's going to regenerate. It regenerates all day, every day, normally, without damage. But the connective tissue doesn't as much. So the epithelia has a really high regenerative capacity, and the underlying connective tissue, the dermal layer, less. And so when you get damage of skin, the reepithelialization that occurs from these basal stem cells, so stem cells right at the bottom layer of the epithelia, they start to, turn into the types of epithelia you need that then grow, divide, and whatever into keratinocytes ultimately. That happens super quick. That's like 48 hours, right, occurring. But the underlying connective tissue is a lot slower. So you've got this new epidermal layer, which is new and pretty weak. And then underlying that, the connective tissue hasn't regenerated yet.
No.
Right? So you've sort of like laying bricks on jelly in a way, right? Yeah. And so you got to be very careful here, because this is, in my eyes, when you were talking about earlier on, if you have continual exposure to a noxious stimuli, it's at this point where you really start to, if you're damaging this weak epithelial layer and this non-existent dermal layer that hasn't regenerated yet, it's going to go, what's the bloody point?
So, okay, well, that's a good example. So if you were to, again, cause skin trauma, but in this case it is a friction or an abrasion injury that's coming from an exercise activity that you're doing. And so let's just say from a poorly fitted shoe, right, and you're doing a lot of running, you're going to cause the skin injury like this. You're going to go through this process, but then if you then put the shoe on again after a couple of days, you're reintroducing the negative stimuli to it. Right. And then if you keep doing this, every week, eventually what you're going to have at the tissue site is a lot of scar tissue.
Yeah.
Because it's the only way that it can close the wound up by a second intention.
Exactly.
Because it's just injuring itself over and over and over again. So it can't re-epithelialize.
You're close.
Rather, it's going to just keep putting collagen into it.
Yeah. So there's the re-epithelialization. And then you've got the angiogenesis. So this, importantly, so fibroblasts.
Yeah.
Bring them in. Bring them into this point.
So again, they're getting signalled by the macrophages to come in.
Because these are probably the most important aspect of the proliferative phase.
Well, at least for the collagen and the ECM.
Yes.
Yes. So they're getting brought in.
Because it's the scaffolding that holds it all together.
They're coming in, they're migrating. And again, this would be an example in atherosclerosis.
Yeah.
They're coming into the area and they're laying down a fibrotic cap.
Yeah.
Which complicates the plaque off, but also stabilizes it.
Yeah.
But in this case, they're just bringing in the collagen fibers and the ECM, which is the extracellular matrix, to lay down all the scaffolding for the epithelialization to occur, to grow on top of it and to slowly close off. So if you're thinking of the second intention, you'd have the wound that's kind of a V-shaped. Initially, you would fill it up with a blood clot. And then you would pull all the debris out of it and you would start to lay down some rudimentary framework. But then at the bottom of the V, the epithelium is slowly migrating up through the clot.
Bottom up. Yeah.
Right? But in doing so, the collagen is kind of reinforcing it to stop pulling apart.
Yes, it's holding it together.
Holding together.
Yeah. So you got fibroblasts producing collagen. This collagen is forming, it's making it stronger. It has a high tensile strength. It's scaffolding in that particular area. And the fibroblasts can also stimulate the angiogenesis too. So that's happening. So all these three things where the epithelial layer is starting to grow and divide from bottom upwards. Then at the same time, you've got the collagen coming in, trying to hold it all together, trying to manage the whole scaffold. And then you've got the blood vessel supply that's being pushed up and through to try and feed it while it's all happening. And then, so this granulation that you see, the red dots that you sort of see in that's this new forming tissue, right? That's all of these things happening together, this granulation, those dots appearing in a new wound or a wound that's healing. So then you've got, once all this has happened, right, the fibroblasts can actually turn into another cell type called myeloblasts.
Myofibroblasts.
Or myofibroblasts. And myo, what does that tell you?
Muscle.
Yeah, and it's not that they're muscle, but they're contractile. And so the great thing is they can sort of hold adjacent cells together and they contract and pull them together, almost like first intention, right? Pulling the edge of the wounds together. And this cross-linking and holding just will help facilitate the final process of closing everything off and basically finalising the remodelling stage or the final stage. But at the same time, like you said earlier, it's sort of like now we're taking the scaffolding away, we're getting rid of all those things that were holding it all together.
But again, depending on
we're not getting rid of collagen.
No, depending on the severity of the injury here, would determine how long remodeling might take, and this could run out months to years.
Yes,
because the wound might be closed, but it's not gone back to its tensile strength.
Yeah,
so it's still subject to be pulled apart, and so a lot of these connective tissue network that's been laid down, they probably want to stay in place until the wound's gone back to its original strength. But maybe the things that regress would be the blood vessels. They may slowly wither away because they're not required anymore. And I guess certain other processes that aren't there, cells will either get killed off or whether they have the ability to migrate to somewhere else, I'm not sure.
Yeah. And then hopefully we've got a healed wound.
Now, if you're going to compare the primary to the secondary in this process, they would carry out the same 4 steps.
Yep.
But because with the second intention, you've got such a big pit that the re-epithelialization takes so long to move up. It's going to take so much longer for that regeneration to take place. And again, because this process is going to be a lot longer, there's more collagen being laid down. And as a result, the tissue would look a bit more scarry because it just hasn't had the chance to go back to its original kind of native tissue.
That's right.
And so in certain particularly in certain ethnic backgrounds, this is more evident. They can get more scarring, whether that's genetics or whether that's skin colour, I'm not sure. But that can lead to things like keloid scarring, which is, that raised scarring that's quite evident. In some people you'll see that. But I'm not sure if that's just genetics of how the wound heals or the type of injury or the skin colour, or maybe it's a combination of all. Yeah. So this is the kind of 4 main steps that have to happen. And like you said, this is probably more apparent within tissue that is on the outside, like epithelial tissue, like skin.
Yeah.
Now, when we look, a couple of final points, have you got anything further to add or you're happy with that?
That's good.
So a couple of further things to add here is, because we're talking clinically here, what can be done or what can be considered that may impact the wound healing process?
Oh, okay.
So there could be certain factors.
As in limited?
Yeah, limited.
Right.
Particularly.
Yep.
So there could be certain factors that are going to impede the ability of the wound to go back to its original.
Can I guess?
Yeah.
I would say underlying chronic illness, right?
Yeah. So the way you can categorise it in local factors versus systemic factors.
All right. So if I were to think about systemic factors, again, underlying chronic illness, so maybe things like diabetes, or particularly unmanaged diabetes, if you've got too much glucose floating through, or glycosylation occurs, damages the blood vessels, it's going to limit that process. You could, let me have a think, local factors. Go, tell me.
Well, I'm
trying to think.
One of the third steps was angiogenesis.
Oh yeah, age. Of course, age.
And with that angiogenesis, what did you say?
You need oxygen and nutrients.
Yeah,
so if you've limited oxygen nutrient supply.
So if you've got poor blood flow to the area, then that's going to limit wound healing.
So that's a local factor.
Yeah.
Yep.
If you've got stuff stuck in there,
like a foreign body.
Yeah. And that would be also a bit like third intention, is if you've got the possibility that there's...
Tertiary intention.
What did I say?
Third.
Yeah, tertiary. If you've got bacteria growing in there, the last thing you want to do is close it.
Of course.
Because then that bacteria will probably have a party in a closed wound.
Tell me about it.
And cause all sorts of crazy
That's where I had my last party.
necrotic tissue, which will just cause sepsis and probably death.
Yeah.
So infection, foreign body,
Yeah.
and then blood flow, just general arterial in, venous out.
So what about systemic?
Systemic, so this is whole body.
Yeah, so
age, particularly, I guess, older age. But
older you get, the less physiological reserve you have. So just your body's ability to be able to withstand and repair diminishes.
Yeah, and that probably big part of that would be the immune system.
Yeah.
How efficient your immune system is to do that cleanup process. Hormonal states, so certain hormones will play different roles in the way that healing process would carry itself out. Stress, so this could be emotional, mental, psychological stress, and we know that when you activate the stress response, one of the big hormones that are released, cortisol, and that can also go in with a type of medication, which is the steroid hormones. And two things that it does, actually 3 things it does that would impact the process we just spoke about is, 1, it's an anti-inflammatory. So you're impairing the inflammatory. That's step 2. And a lot of people think that inflammation is a negative thing, but in many cases it's vital for the repair of the tissue.
Yeah.
So
inflammation long-term is negative.
So we shouldn't always try to inhibit inflammation.
Correct.
It plays an important role. And so the steroid hormones or the stress hormone is going to inhibit the inflammatory process. That's step 2. But it's also going to inhibit immune response. So a lot of those cells that we spoke about are probably going to be less efficient to come in and clean up. So they're not doing that as well. But the third big thing it does, it's a catabolic hormone. And so it's not moving towards anabolism, which what you want to do, which is laying down protein, collagen. It's doing the opposite.
Yeah.
It's taking it away.
Yeah.
So you're not reinforcing the wound, you're actually making it thinner.
Yeah.
So more vulnerable, right? Then you've got other medications, so like chemotherapy. That's where, people have taken it for cancer treatments, and they're going to run the risk of getting wound breakdowns or even just skin breakdowns, right? And nutrition. So we've spoken about before, one really important vitamin is vitamin C, which plays an important role for collagen production, but also just protein nutrition. So
and we also said vitamin K for clotting.
Yep.
You need calcium in that process as well. So a whole bunch of these processes.
So an important factor here is if you are a clinician and you're looking after a patient with serious wounds, you want to ensure a lot of these factors are well looked after for their regeneration.
Yeah, absolutely.
One final thing. So we've spoken about, do you think we've spoken enough about the fibrosis process when there's too much injurious agents over long periods of time?
Probably.
So. Right?
Yeah, I think so.
Okay. Just a final couple of points I just wanted to mention with wounds and maybe not the complications of, but wounds that can come about from a skin standpoint that is underpinned by other clinical manifestations. So you spoke about diabetes, and one serious side effect of diabetes is diabetic ulcers. And so why that comes about, so this is where, people with particularly type 2 diabetes, they would start to develop certain unhealed wounds that just stay open and then run the risk of being infected and become necrotic and then resulting in that part of the body having to be removed, like the toes or feet. Part of the reason for why that is, and you spoke to that, is the high sugar over time glycosylates tissue, which then causes the breakdown. It also changes the sensation of the area, so it causes like a neuropathy. So the people can't feel that they've injured their tissue. And then on top of that, they've also probably got peripheral vascular disease, so they've got poor arterial blood flow. And then on top of that, their blood is so sugary that the bacteria grow or love to grow on it or in it. And so that just makes it a perfect environment for infection and not wound healing.
Yeah, exactly.
A couple of the others is pressure sores. So this is usually where skin is in close proximity to a bony, what do you call it, protuberance or something, and it's being compressed in bed. So the back of the heel or the sacrum. And that's, again, you're cutting blood supply to that area, you're getting kind of edema, and then you're getting tissue breakdown, and then the wound is just worsening because you can't heal it.
Yes, you're not letting it heal. You don't know. That's why rolling patients, trying to find the sores. And
then the other two is just arterial ulcers versus venous ulcers, which is either a combination of not enough blood to the area and you get the tissue breakdown, which is fairly common, or the venous ulcers where you have stagnation and you get legs that are full of edema and you're not getting blood leaving the area, and you get the same kind of issue where the tissues are breaking down and the healing process is exaggerated and lengthened, and we run the risk of these being infected and serious complications. So they're kind of 4 examples of wounds that come about through disease processes or poorly managed health that can exacerbate the whole situation.
Perfect.
So there we go.
Good job. Well, I hope, dear listener, that you enjoyed wound healing. Like I said, you can comment or write a question. Go to our website, drmattdrmike.com.au, or you can send us an email, gubiosciences@gmail.com, or you can visit us on social media, specifically me. He's not on it. Dr. Mike Todorovic at whatever, or at Dr. Mike Todorovic. I was bugging that one up. At DRMIKETODORVIC on all good social media platforms, and even the bad ones. So, so I will see you there, Maddie. Thank you so much, and we will speak.
That was a healing. That was a healing.
Oh, that's very nice. Well, let's
process with you, actually.
Well, let's hope that the next one is more emotionally healing than physically. Hi everyone, Dr. Mike here. If you enjoyed this video, please hit like and subscribe. We've got hundreds of others just like this. If you want to contact us, please do so on social media. We are on Instagram, Twitter and TikTok at Dr. Mike Todorovic, at DRMIKETODOROVIC. Speak to you soon.